All right. We are in section 1.1 and we're looking at functions. A function is a special kind of correspondence. And a correspondence is simply a rule that maps one group onto another. Um, mm, there are four kinds of correspondences. The first is called a one-to-one correspondence. For example, x plus 3 is a one-to-one correspondence. The first set is called a domain. Let's put it here, 0, 1, and 2. Your second set is called your range. Your domain can have more than 3 numbers. I'm just simplifying here. In fact, your domain can have an infinite number of numbers. But we'll simply plug in 0. 0 plus 3 is 3. Plug in 1, you get 4. And so we say 1 is mapped onto 4. Plug in 2, and you get 5. And so 2 is mapped onto 5. This right here is your one-to-one correspondence. Your second kind of correspondence is a one-to-many correspondence. And in your one-to-many correspondence, for instance, say the square root right here. Let's go with 0, that's not a 0, 0, 1, and 4. The square root of 0 is just 0. The square root of 1 is actually negative 1 and 1. So one item gets mapped onto many items. The square root of 4 is actually negative 2 and 2. So 4 gets mapped onto. And so what you have is at least one item being mapped onto many items, one item in the domain being mapped onto many items in the range, and we call that a one-to-many correspondence. Then you have your many-to-one correspondence. Say, for instance, x squared. Let's go with my domain 0, 1, negative 1, 2, and negative 2. Well, 0 squared is 0, so 0 gets mapped onto 0. 1 squared is 1, but negative 1 squared is also 1. So you have many items being mapped onto one item. 2 squared is 4, but negative 2 squared is also 4. Domain, range, and so you have a many-to-one correspondence. The final correspondence is a many-to-many correspondence. That's a combination of the previous two. And in a many-to-many correspondence, let's say we have A, B, C, and then 1, 2, 3. A, B, C. Anyways, and basically you have both happening. So you have one item being mapped onto many items, and then you have many items being mapped onto one item. When you have this happening, you have a many-to-many relationship. A function is a correspondence where every element in the domain is mapped onto one and only one element in the range. When you have that happening, you have a function. The simplest way to think about it is that when you plug in a number, you only get one answer. And therefore, that leaves us with only two possibilities. Your one-to-one correspondence and your many-to-one correspondence are your only two functions. So this one right here is a function. And this one right here is a function. Again, the basic idea is if I plug in the number 1, the basic idea is if I plug in the number 1, I will only get one answer. Up here, for instance, by plugging in the number 1, I actually get 2 answers, 1 or negative 1, and therefore this is not a function. To tell if we have a function, so another example, if I have a set of ordered pairs 1, 1, 2, 5, 3, 7, and then say 1, 8 right here, this set of ordered pairs, this set of ordered pairs right here is not a function. Because for one of the domain elements, the value 1, for one of the domain elements, the value 1, I actually get 2 different output values. Once that happens, it cannot be a function. Every x value can only correspond to one y value. Graphically, we use what's called the vertical line test. Let's say I have this function right here, or this graph right here. I can't say this function yet. And then this graph right here. Well, we use what's called the vertical line test. Any vertical line that I draw must go through the graph exactly once. Any vertical line that I draw. This one right here passes the vertical line test. And so is a function. But this one right here, if I draw a vertical line, you will notice right here that the vertical line cuts the function more than once. What this indicates, say for this is x equals 2, what this indicates is that x equals 2 has 2 outputs, say 2, 5, and down here 2, negative 5. And thus breaks the rule where one element, every element in the domain is mapped onto one element in the range, and so the vertical line test, so it fails the vertical line test, and therefore is not a function. How sad. All right.